Okay, so vaccinations. Let's start again. So vaccinations, the deadline to get the Pfizer vaccine is September 2nd. After September 2nd, the only other vaccine you can get that will comply with the CUNY mandate is the Johnson & Johnson. All informations must be uploaded by October 7th. I mean, sorry, not uploaded, must be approved by October 7th. So you have 10 days before October 7th to upload your documents. So please upload them before October 7th. After October 7th, CUNY will, or let's say, has the right to start removing you from class via academic withdrawal. Unless you're one of the few groups who have an exemption from the rules, then you won't have to worry about that, but you will still have to get tested 7 days before every time you come on campus. So September 2nd is the last day to get the vaccine, the Pfizer the 2-shot Pfizer vaccine, for you to comply with CUNY vaccine mandate.
The reason that I asked you, Professor, is because on our on the syllabus, it says the first class will be held online and the other ones will be in person. So I was under the impression that we will be coming in person from next week.
Yes, that is true. We were all under the same impression too. The chemistry department made the syllabus that way, under the impression that we have the go ahead to have classes online. But as of this moment, Queens College and CUNY in general does not give us the permission to have in-person classes yet. So the syllabus is wrong. So that's the best way I can say. The syllabus at this moment is wrong. So until we get the go ahead, we will have online meetings, and I will keep you guys updated about when we will actually start coming into lab. So, but we will, there is hope that we should start having in-person labs soon. The more students get vaccinated and upload the information, then the faster we'll be able to come to lab. Give me 1 second, let me just read the text. Okay, so then okay, Everbridge is not where you upload the documents. The documents must be uploaded to CUNY first. Does anyone not know how to upload their documents to CUNY first? Yes, there's no class next week. Next week, Monday, Tuesday, Wednesday, there's no class. So we won't see each other for about 2 weeks. So somebody already answered on the documents on CUNY first. Yes, and you'll get the VaxPass as soon as 10 days after you've uploaded your second shot for the Pfizer and Moderna, or the first shot after Johnson & Johnson. All right, any other questions about the vaccine?
Professor?
Yes?
So the VaxPass is just like an email that they send you, right?
Okay, so the VaxPass is like, how do I say, the VaxPass is proof that you uploaded all your information onto CUNY first and it has been approved. If you have the VaxPass on your app, that means you will be granted access to Queens College via your Q card.
Oh, sorry, go ahead.
Anyone, please.
So, Professor, I actually don't have a Q card because I was transferred to Queens College during pandemic, and I haven't been able to go in person to make one. So if I do have the VaxPass, but I don't have a Q card, like, can I not get inside the college? And also, can I only go to campus if I have a class, or like if I want to go to the library to get some materials, can I still go in?
Okay, so if you have the VaxPass, then your vaccine, then your information is good to go. So you need to get the Q card, right? So the Q card there's a way to get the Q card. You have to, I don't know who to contact, but I could get the information for you guys. But all you have to do is submit a photo ID, a picture of yourself to this I think the IT department, and they will issue you a Q card. And the Q card you could pick up through campus security in the main gate on Casino Boulevard. Once you've sent the IT department your picture, they'll make the Q card for you. They'll leave it with safety, and then you could pick it up there. So you'll be able to pick up your Q card at that location. I'll get the you guys should have received an email from Queens College saying how to do or how to get your issued Q card. And regarding other information, I believe the library is not open yet for students, and it might be soon, depending on how many students are vaccinated. And so once that is open, then you will not need permission to get onto campus. But I don't know if you could get onto campus at any time willingly. But I believe you will definitely be able to get onto campus the days you have class. And if you want to visit the library, just wait for further information from the college about when library will open. But I believe it will be the same procedure. As if you have your Vax Pass or if you have your Q card, then you'll be set to go. You'll be able to enter the library.
Thank you, Professor.
No problem. Brooke, I don't know about the religious exemption. That's something you have to hear. I don't have any information on that, or we were actually not giving any. We were not given any information from the college about exemptions, only the vaccination. So you would have to follow that up with, I believe, whoever's in charge of that. I don't know who that is, but I'll try to find out for you.
Thank you so much. Also,
Yeah,
if
just-
anyone else knows, please PM me through Zoom or something. Thank you.
The Malika, the Everbridge app is so if you don't, you need the Everbridge app is a way to show that you're proof of vaccinated. So if you don't have the Everbridge app, then you need to get vaccinated. Talking still on vaccinations. If you do not know where to get vaccines, you can get vaccines at Queens College. Queens College is offering I believe both Johnson & Johnson and the Pfizer. So if you guys need to get vaccinated, you could come to Queens College. No appointment is needed. And if you want to get tested, and if you are one of those students who are exempt or do not have the vaccine, you must get tested. And you must get, I believe, get tested from a Queens College site. So 7 days before your next class, you must get tested. And then you will have to wait, I think it's 24 hours. All right, I think CUNY has the best, fastest PCR test. And also, on a side note, we if you guys take Dr. Dennehy actually himself does PCR examinations. So yeah.
Professor, I could tell them about the Excelsior pass. Someone is asking in the chat.
I tried uploading my vaccine. Oh, I see it. I'm sure. I tried uploading.
Or you could go ahead.
But I tried uploading my vaccine card, but it said I also need an Excelsior. Okay, so all right, let's go through this together. All right, I'm gonna show you guys what to do. Give me 1 second. Okay, first thing you would do is log into CUNY first, right? Log in, CUNY first. And you get this menu, right? Everybody knows how to do that, right? Anybody that does not know how to do that? Anybody new to campus or new to CUNY? Okay, I'll take that as everybody knows how to do that. So once you log on to CUNY first, you go to vaccination verification, right? Once you go to vaccine verification, you come to this drop-down menu, right? And it says all this, blah, 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 blah. And then you see Pfizer, first dose, Pfizer, second dose, right? And it gives you option about so you vaccinated, medical exemption, religious exemption. So you pick one of the options and you choose, right? So I was vaccinated, so I pressed vaccinated and it gave me options for 2 shots, for 2 doses. So first I picked the first dose, I enter the information. Second dose, I enter the information, right? And then it says, I have a valid New York State Excelsior Pass. At this time, when I was doing the vaccine verification, I did not have the Excelsior Pass, so I did not press this option. You don't need to press it. If you have the Excelsior Pass, you can press the option and fill out the information they require. If you don't have it, like I didn't, you don't need to press this button. So you don't have to press the button if you have the Excelsior Pass. If you do, then you can press it and then fill out the information it asks you. So then you go down and they have a option for you to upload your vaccine information, your picture of the vaccine or the scan video, not video, the scan image. So you upload it, and then you wait about 10 days, and then you get here, and then it will tell you attestation, you enter yes, and then you're good to go. So look back here periodically to see if you missed anything. So if you accidentally put the wrong date, if these dates don't match the dates on your vaccine image, then you will get a note here saying this image do not match this, please resubmit. So just watch out for that. That happened to me. I accidentally put the wrong dates. I came here to see what was going on. They said I put the wrong date, fixed the date issue, and I believe a couple days later, I received my Vax Pass. Okay, so that's how you would do to, this is how you would enter the information on vaccine verification. Any questions? Yes, you don't need both. You just need to do either one or the, I believe it's one or the other.
I thought both was mandatory, so
No, both is
did
not
both.
mandatory. Just one of them is mandatory. Any other questions regarding anything? So to just go over what's happening at this moment, everything will be online until further notice. As soon as I get information about if we will have classes online, I will email you guys immediately, okay? So as of this moment, class will be online and not in person. So that means I'll upload data sheets every week for you guys to use to do the lab, and we'll go through the lab together, okay? All right, so I guess we could start with the syllabus. Again, any more questions regarding vaccine or any other issues you guys have besides the syllabus? Or just general questions? Just a raise of hands, who has not ever entered Queens College? Or just put in the group chat. Okay, let's see how many students. 1, 2, 3, 3, 4, 5, 6, 7. Okay, so 70 of you, I'm guessing there's probably more, but I tried to say, but 70 of you guys have not entered Queens College, right? So no, the question is, how many students have not entered Queens College? Okay, so there are more. Okay, all right. Yeah.
Maybe you can give us a tour of the campus after class if we do have one, because we don't know anything about Queens College at all.
Okay, yeah, sure. If we have time, then if depending on where we get there, if we are allowed, then of course I could show you guys around the campus. Okay, so Christina was on the campus. And I've been there. Okay, and you were in lab for general chemistry 1, I believe, right? Okay, all right, good. So you have seen the campus, but have you entered any building besides Remsen? Another question, yes. So you haven't, no, okay. So Remsen and Christina was in, okay, cool. So the campus is actually really beautiful. If you guys get a chance, the fountain has, you guys can see the overview of the city from the fountain area. Do you guys know that? Or the students who have been there, have you realized that? No. All right, so yes, so you guys can see, and it's a very good view of the city. Yes, at nighttime it's, how can I say, it's even better. So hopefully you guys will be able to get there soon, and then, you know, just walk around campus. The campus is pretty enclosed area, so all the buildings are really nice next to each other. The most modern building, I believe, is the science building because it's called the New Science Building. It's called new because we haven't found anyone who wants to fund the building, so we haven't named it yet. So that's why we call it the New Science Building. But that's one of the brand new buildings. how many? Yes, Queens Hall is where all what do you call it? Majority of your language classes will be held Queens Hall. There are some other classes there, but majority of the classes will be Queens Hall. If you guys are taking Bio 105 or 106, it's usually done in Kali Hall. The big, really, really huge lecture rooms are in Kali Hall and Remsen 105, no, 101 and 102. 101 is where all all chemistry lectures are held, and I believe 102 is where biology lecture halls are held. Remsen itself is just a chemistry building. All the chemistry classes are held in Remsen. Lecture and lab. All right, so we'll stop. Any other questions about Queens College or its surroundings? All right, so we'll start with the syllabus. All right, is everyone able to see the syllabus? All right, perfect. Okay, so the course, we are section 1, I believe, for this course. It is held from Tuesday, 7:30 to 10:20. So if you haven't had lunch or dinner, please do so before you come, because we'll be there for a long time. Or if you're doing that, will in person, we'll be there for a long time. But if it's online, we might also be here for a long time. But if you guys are at home, enjoy your lunch and dinner, or both of them at the same time. All right. Okay, so the lab coordinator is Professor Edward Look. If I have any question that I am not able to answer, I will directly send you to him. He will definitely have the answer to stuff that I don't have. So if you are for some reason do contract COVID and we are in person, please let me know immediately, so I can let Dr. Look know, and we can go about it in a proper manner. Okay. So if there's things I can't answer, then he will definitely know how to answer it. All right. So as it's saying hybrid, so hopefully we will be able to get to come to campus. So at this moment it is online, but hopefully we will be able to go on campus. So as said, first lab is synchronous, and the future labs will also be synchronous. Please use the same link for future online classes. Okay. So my office hours will be Tuesday from 6 p.m. to 7 p.m. So that's an hour before our lab. So I'll also give you the link. All office hours will be held virtually. Even if you do come in lab, it'll be held virtually, and I'll send you guys a link for that by tomorrow. Okay. So general laboratory rules, please you cannot wear contact lenses, always wear goggles, no short pants, no short skirts, no open toes, shoes must be closed, do not chew gum, have any beverages or anything should not be brought into the lab. Please leave all that outside. And also no laptops or iPads or any type of tablet allowed on campus. Everything must be either in the authorized book that you're supposed to have for lab. Okay. Any questions regarding those? So you cannot wear contacts at all. There are no contacts allowed in lab. You have to wear, you have to either remove them before you come to get into lab. If you're far-eyed, you could probably pick a seat close to the board so you can see it. But if you're nearsighted, then I guess it shouldn't be a problem. But you cannot wear contacts. That's one rule I cannot, or no one can break. Lab coats and goggles will be provided to you on the first day of lab, if we do have in person. Okay, so these rules are only implemented for in person. So right now you don't really have to follow these rules because we don't know when in person is going to start. But when in person do start or does start, you must follow these guidelines. Okay. Lab coats and goggles and everything you need will be provided to you by the stock room once we start in-person labs. All right.
Professor,
Yes.
is the lab book just the lab manual that you uploaded on Blackboard, or is there any other book that we're supposed to have?
So you have, I believe all the lab manuals are posted already by Dr. Look, right? Under course, I believe the course manual, right? There should be something under lab manual where you see all the lab manuals, correct? Or you don't see that, or you guys
Yes,
don't?
I see that. I just want to like ask if there's like anything else that I need to like. Is there?
No, that's all at this moment. Those are all the information you need. If the data sets that you will that will be provided by me. I will upload it a day before or the night before we have lab, and that data set will be used so you could do your lab. Okay, since we're not having in-person labs for the few weeks, the data set you need to do the labs will be given to you by me. Okay.
Thank you.
No problem. Okay, so when it comes to chemicals, there are some harmful chemicals. This is a chemistry lab, right? So anything chemistry-wise is harmful to you. So that's why you shouldn't be wearing contacts. But if you do have issues, the chemicals we use, I believe, I'm not a medical expert, but please, if you do have any options, please talk to your PCP about it. But you could check up what chemicals are needed every time, but please contact your PCP. And also I would involving this question, I will forward you to Dr. Look, okay? But also please email me separately so I don't forget to email you to don't forget to bring this topic up, okay? Okay, so continuing with the syllabus. So in-person labs, when you do come to in-person labs, you must have a lab manual. Has anyone seen or have gotten the lab manual, not lab manual, sorry, the lab book that is required of you for this class? Okay, I see one yes. Anyone? Okay, so the lab manual is supposed to be, not a lab manual, I keep saying lab manual, sorry. The lab book should be posted on the bookstore on CUNY, not CUNY first, but the Queens College bookstore. It is a binding notebook with carbonless paper. So that's the requirement, is a binding notebook with tearable carbonless paper. So if you could find one cheaper on Amazon or eBay, that's fine. But you could please double check with me. If you do buy it on Amazon or eBay, just send me the link, right? And I'll look at it, and if it's good, I'll tell you it's good, you can buy it. And if you can't, and if it's not, then you can just buy the one on the website, on the bookstore website. So the requirements for the lab notebook is, where is it? Laboratory notebook. Give me 1 second. Oh, where did it go? Where does it laboratory notebook? Carbonless something notebook, it says. Where did it go? Check in pre-lab. Where is it? Pre-lab. Okay, pre-lab, right? So pre-lab, writing in your own words, blah, 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 blah. ISBN, right? So this is the ISBN that you will need for the book. But the book has to be, the lab notebook has to be a carbonless paper, tearable book. Let me show you guys again. Hold on 1 second. Let me show you guys. Okay, so carbon, so these are all books that you could buy. So this is a lab notebook, 100 carbonless spiral notebook. This is one you could buy. This is how much? $20, right? So if you don't want to buy this, then you could log into the bookstore website and buy the one that's on the bookstore. But this is the type of notebook you need. Carbonless pages, spiral bound, and you could and these are also tearable because when you hand in the pre-labs, when we do meet in person, you must tear out the pre-lab, bring that to you, and that's what you will use to do the experiment. Okay? Any questions? No? Okay. All right, we'll continue. Okay, so that's the notebook that you need. Okay, so going back to this. So laboratory reports are, so each laboratory report, you have to do the pre-lab. Pre-lab should be the theory, the introduction, and the, what do you call it? And the procedure. If you have these three, if you have the procedure written down on pre-lab, it will make lab going faster, okay? Lab will go by faster and then you could finish and also safer because you know what chemicals you're dealing with. In the pre-lab, you should write down the procedure and also the chemicals you're dealing with. So that when you know what's harmful, what's not harmful, and what to do and how to take care of it. I will be there, so I will give you guys tips and safety tips when you guys are doing it. But at the moment, but you guys should also do the pre-lab. And the pre-labs will be graded. So if you're gonna have a pre-lab for a specific lab, it will be a minus of 5 points. Okay. And pre-labs are only for when we actually start lab. So if classes continue online, then you obviously don't need a pre-lab because you're not doing the experiments. But pre-labs must be done when we do start coming in person. You could do the pre-lab, or also what you could do is you could print out the manual and bring the manual with you. But you must have the pre-lab because that's just easier way for you to write down all the procedure. And as stated here, the pre-lab, if once you've done the pre-lab, that's all. The pre-lab can be directly added to your laboratory, your final laboratory report for that week. Okay, so it's just you're killing two birds with one stone. You're making time go faster during the day of the experiment, and when you're actually writing your report, it's going to go by faster because you already have the abstract, the introduction, and the procedure. Okay, so the formatting, right? So let's go to the formatting. Anyone have any question about the pre-lab? So let's start with that. So pre-labs will be mandatory when we actually do come in person. At this, if we continue doing online, then it's not mandatory because you don't really need a pre-lab. But once we start coming in person, pre-labs will be mandatory. Okay. All right. So let me show you guys. Okay, so let me just go through this first, and I'll give you an example. So introduction, then experimentals, which write in the data. So this lab is called qualitative and quantitative analysis. So you will do a lot of graphing. If you are not well versed in Excel, this lab or this course will help you get better in Excel. It may not, you may not be the best person in Excel, but you will learn a lot of Excel through this course. And you will also learn, and it's quantitative. So you will be doing a lot of calculations. So if you're not good at math, or your math skills aren't really that up to par, then it's fine. Even when I was taking this course, I wasn't the best. My math skills weren't on par and my Excel skills weren't that good, so it's fine. Just email me and I'm gladly to help you, or come to office hours. I'll guide you through everything, okay? Because I know there's a lot of things, there's a lot of Excel stuff that was not taught, and they think you will know it, but I know firsthand you guys will not know it. Some of you guys might, or some of you guys have older siblings who know this, fine. And if you guys don't, please feel free to email me, because 6 years ago, I was one of you guys. I had trouble, so don't worry about it. All right. So I will be looking for all of this in your lab report. All right. Lab reports do not have to be long. I'll say this again. Lab reports do not have to be long. As long as you come clean to the point about everything, you will get a good grade. There is, but you must follow these steps. If you are missing any of these 8 sections of the lab report, that's an automatic 10 points off. Automatic. So each of these sections are 10 points. Okay. So if you're missing one of them, you lose 10 points. So please do not miss any of these sections. All right. So if you have all of these sections, that's automatically 50 points. What is it? Almost 80 points right there, right? Not 80 points, but let's say 50. If you have all these, you start off with a 50 already, right? Yes, Shaman, go ahead.
So for example, you know how they have the calculation and results combined?
Yes.
For some of the lab, what if we combine the discussion and the conclusion? Would that be considered 2 sections or just 1 section?
That'd be considered 1 section. So you have a discussion, because in the discussion, there are certain labs that you have to answer questions to. And there's certain questions, and there are certain information that you must discuss in the discussion from your results. Conclusion is just a summary of the lab, okay? So there are 2 different parts. You must have a discussion and you must have a conclusion. Please do not mix up discussion and conclusion. Last semester, a lot of students did that and they lost points for it, okay? So you have a 50 points on your lab report just by having the formatting. If you have all of these 8, that's automatic 50. If you are missing 8, you're already starting off with a 40, okay? So discussion and conclusion are 2 separate things. You cannot mix them into one. All right, so we have the heading. Heading is very simple. No cover page. Please do not include a cover page. Don't include a cover page. I don't need an extra page for cover, whatever. Just put everything in, just start off with a heading. I'll show you guys how to do the heading. So then the abstract is short summary of the entire paper. Introduction is, if there's a theory, like today we're talking about boiling points, right? Boiling points, you have in introduction, you must explain what boiling points are. What goes into boiling points? How are boiling points, determined? What plays an aspect of boiling points? What causes something to have a lower boiling point? What causes something to have a higher boiling point? Okay. Anything that's theory-wise must be in the introduction for all the labs. Some of the stuff you don't really need. There's not too much to write for introduction, but many. I think about 8 of the labs you need an introduction. There's one lab, Le Chatelier's principle, the first one. You don't need. I don't think you don't need really an introduction, because that's just data sets, right? And then there's, I think one of them, I forgot what the other lab, the equilibrium lab, right? Part 1, you don't really need an introduction, because it's just all, you just have to literally just print out the information or just enter the information in the blanks and you hand that in, okay? So, but almost all the labs will have an introduction. And the introductions, you explain what the theory behind the experiment is, anything that will help you with the experiment, what are the calculations, what are the equations being used in the experimentation, or explain the equations or any of the theory that goes behind it. All right. Experimental is basically the steps. Experimental, please don't write step by step. Write in a paragraph form. Don't write bulletins. Don't write bullets. Just write paragraph form. Okay. And the data. So since the class until further notice will be in person, what you guys can do, if there is calculations, you guys could either handwrite the calculations, take a picture, scan it, and then upload it to as part of your report, or you could just do it on the computer on Word and just do it that way if you guys like it. So either way is fine when you guys are doing it. You guys can handwrite it, take a picture, and add that into your report, or if you want to do it on Microsoft Word, that's also fine. Either way is fine for me, okay? Any questions about that?
Actually, so I'm saying when we go in person for the data, we'll have the data from the class from the experiment. do
Yeah.
we need to, so we can just submit a picture of that for our report, right?
Yes,
For
of
the
course.
data section.
Yes.
Okay.
So there'll be calculations and there'll be calculations for those datas, right? Those you can do the calculation by hand and enter that and by hand and then add that to your report, because those reports will be giving in person. Give me one second. And they will, and then you could just add the results to your what do you call it, to your report. Okay, so you don't really have to write back everything. You could just show it, show the results, calculations, and any other data sets you need to do at home. Just take a picture of it and upload it to your well, also no, well, you don't, if you do the calculation and results there, you're gonna have to attach your pre-lab to your final report, right? So if you do everything there, that's fine, right? I will see it, and you don't really have to put all that back into your data and results. If there are some graphing you have to do, the graphing will be in your data results section, right? But if you do the calculation and the data during the pre-lab and you have it in the pre-lab, you're going to detach it and attach it to your final lab report, and that's what I'll see for the in-person labs. But for the online lab, you could just scan it and just submit it, okay, onto your report. But make sure when you scan and submit it, you put it in the right section. So for data, then you have all the images you want to add in the data section. Does that answer your question or no?
It's a little, it seems a little complicated right now. I guess when the time
let me-
comes, we'll make it better.
Let's start again. So when you come, you have a pre-lab, right? The pre-lab, you have everything right now. When you are doing the experiment, you will write in your notebook, your lab notebook, everything you have done. So let's say when we're doing the reaction with the iron sulfur something, right? You write down how much milliliters of the solvent you added. That will be written on in your pre-lab, right? The lab notebook that you bring. So that data will be attached to your final lab report, and I'll see that data. All you would have to do is just show the calculations. Or you could do the calculations by hand on that notebook, right? Your pre-lab note, your lab notebook, or you could show the calculations in Microsoft Word.
But if we do that, then we're giving you the data calculation and the result on like the same page, because they're sort of connected, because we're getting the calculation and the result from the data. So
Yeah.
how do we separate the?
Okay, so let's say for example the iron table content we'll do next lab, right? Let's say you actually came in person, right? In person you did the lab, and no, sorry, it's not iron content, it's Beer's law, whatever that thing is. You will get the reports. You'll write down, oh, I received this, I received this, I received this. That's already done while you're doing an experiment, right? Those are the numbers you've got. And now for the data and results, you have to show there's an equation we would use to solve for that. And that's what I want to see in the data section, right? I see the data, but if you have to do calculations, and that's where you also put in the data section. You get it? No?
Yeah, I get it. Thank you.
Okay. Let's worry about that when we actually have in person. But at this moment, the data you can just, once you do it on a piece of paper, then you can just add it on to the data section. Okay. So it says data and calculation and results, right? So data itself is if we had in person is the pre-lab, and it's a pre-lab plus all the data you have written down while doing experiment. So that's the data part. But since we actually don't have, you won't have actual, what do you call it, experiment results, I'm giving you the data. So I know the data. So until the future, we don't really have a data section, right? Because I'm giving you the data. What you could do is you just copy that data and put it there, and I know what it is. So for the future labs, until we have it in person, there's not that much data that will be there because I'm giving you the data. So you will have only calculations and results. Okay. So the calculation result is, like I said, it's where graphs and diagrams you'll need. For the first lab, today's lab, it's going to be all graphing. You will have to graph the data sets yourself. okay? And that's where you put in calculations and results, okay? Any questions? Don't be shy. If you guys are confused, it's totally fine. Just I'm speaking a little fast because
Yeah, can I just ask you, where exactly do you want the pre-lab? Like we should write it out in our lab report or we should handwrite it in a notebook? Like where exactly should it be?
okay, so you guys remember the lab notebook I just showed you that you have to buy the carbonless thing, carbonless book. So that's the notebook you're supposed to have for lab. That's where you also write the pre-lab. So that in that notebook, you write down all the data you received during the experimentation. And that's also where you write the pre-lab. So that's basically what data is. So you see the number 5 here, that's basically your data. Calculation and results is what you do with the data to answer any of the questions in the lab manual, okay?
Yeah, thank you.
Please ask any question. We have a lot more time, so don't be shy.
So now that we're staying online for the most part, you said we don't have to do a pre-lab, but we
Yeah.
obviously have to do a lab report. Are you gonna put something on Blackboard for us to hand that in, or do we email it to you?
Yes, so every week until further notice, I will upload places where you could do your assignments. There's a folder on Blackboard that says assignments, and it'll be in sequential order. So you have assignments that we do for assignment 1 will be lab 1, then you have lab 2, then you have lab 3, and lab so on and so forth, okay? If you look under assignments, that's where you will upload your documents or your lab reports. So lab reports, we'll get back to that later, okay? I'll answer that question in a little while after we go through this, okay? So then discussion is, in the lab manual, they ask questions about, after getting these results, what do you think about this, about that? So that's where, the discussion is where you answer the questions for the lab manuals. I will be looking if you guys, last semester, a lot of students forgot to answer the questions in the lab manual and points were deducted. So please, if there are questions in the lab manual, please answer them in a discussion. So discussion is where you talk about any experimental errors, do you think the results were good, the results were bad, why do you think this, and also explain why. So for today's lab, the boiling point lab, you would explain why you think the compounds you received did not follow the trend line, and you could explain that. So this is where you explain your results and answer the questions, okay? And conclusion is just a summary of what you did. So conclusion, maybe you just need a paragraph. It shouldn't be that long. All right? Any questions so far about the formatting? Yes, pre-labs are not mandatory until we actually start going to in-person labs. Yes, that's correct. All right, so go back. Reports don't have to be long, please, guys. So I am a graduate student, so I'm actually doing research and teaching an organic chemistry 2 lab. Please don't hand in a 10-page report when you don't need to. If you're handing a 10-page report, please let 5 of them be graphs. That's fine. If 5 of them are graphs and then the 5 are just writing, I am fine with that. Reports don't have to be long, please. You don't have to fluff up your information, please. If you could do a report and it's 5 pages and there's minimal of graphs, that's fine. And that's double spaced too. Please don't write too much. Please. Okay? Please. And also, remember, formatting is very important. So if you just go straight to the point, will be the best for me, okay? Last semester, I know students who wrote a lot got A's. I know students who wrote just enough got A's. I know students who barely wrote, they still did well, okay? So please, just get to the point as fast as you can, okay? Also, late reports. Late reports, depending on the week, because sometimes there are exams during the week for you guys. If there is, I will ask you guys. And then maybe I'll postpone the lab reports. So depending on what's going on that week for you guys, I'll take into consideration if I'll postpone the lab reports or not. But lab reports are due the next following week. Okay? So you have about a week to do your lab report. If you need extra time, you can email me. And if you guys all have like an exam that week or an exam that day, or just let me know and I'll postpone it for everyone, okay? But lab reports are due it will be due 12 o'clock next week, the following week, okay? So every midnight, it will be due. All right? So the boiling point lab will be due next week, Tuesday, midnight. Any questions about that?
By next week, do you mean the week of the 14th of September?
Yes, because we don't meet next week. So so boiling point labs will be due September, let me just make September 14th. Yes, Matthew, you're correct. Okay, so September 14th at 11:59 is when your first lab report will be due. Okay?
We give it to you through Blackboard?
No, so this will be uploaded to Blackboard. When we actually start meeting in person, then you guys will help hand me a physical copy. But until now, it'll be uploaded on Blackboard.
Got it.
Professor,
Yes.
do you have like a lab report template possibly?
It's right here.
Okay.
Heading, abstract, introduction, experimental. You mean like an actual lab report?
Like, yeah.
Okay, I have one, but this is from a lab partner from one of the someone in my lab. He took this long time ago. So let's see how he did it. He just sent it to me. Give me 1 second. This is not a good example. I can't share this with you guys because he's missing a lot of the stuff. So yeah, let me see if I can find another one. Give me 1 second.
If it's more convenient, you could just find it another time. It's fine.
No, it's fine. This takes forever for this to work. All right, give me 1 second. Yeah, 15 pages for, please, if you send me 15 pages, please reconsider everything. I'm not gonna sit there and read 15 pages of anything. Share screen. So this is a model of what just the formatting. This student, well, actually, this student actually wrote everything what he had to write. So you have the title, exploring boiling points, when it's due. Then you have the abstract, introduction, straight to the point. The student didn't write anything that's not needed for this. He was straight to the point, experimental, and then the data. So over here, as you can see, the data was given to him already. So he just posted the data, he just copied and pasted, and these are his results. And then calculations and results. That should actually, calculation results, he explained why some of them were, had higher boiling point, lower boiling point, and discussions. He explained about what the reasons were behind it, and then conclusion, right? So he just stuck to the formatting. If you stick to the formatting and get directly to the point, I guarantee you will get an A for every lab, right? But make sure you actually, okay, how to do the graphs? That's gonna take a long, like put it in our, oh, so the graphs can be done, these graphs can be done on Excel. Do you know how to use Excel? No? So let's say I don't have a data set, but I'll show you guys one thing. Yeah, you could, whatever software you need to use to make the graph, you can use. All you have to do is just copy the graph and paste it. So if you do the graphs on Excel, or you could just copy and paste the graph onto Word. And if you use Google Sheets, you could just copy and paste the graph onto Microsoft. They're both, Google and, well, Excel itself is the same, right? Because Excel and Microsoft Word are part of the same company, right? They're all made by Microsoft. So if you once you make the graph on Excel, then you could just copy it and paste it onto your Word document. And if you're using Google Sheets, I believe you could do the same thing. Okay. And also when you're doing graphs, please make sure the graphs are done correctly. Very important. When you do any graphs in this class or future classes, graphs must have an X label on the X-axis, label on the X-axis, label on the Y-axis, and a heading. You must have these three on every graph. If you do not have those three on the graph, then points will be deducted, okay? So a title on the Y-axis, a title on the X-axis, and overall heading. Any other questions? Okay, all right, so very important. So it says eye protection. So if you do not, if for any reason that you do not comply with any of the safety regulations when we are in person, I will ask you to leave the lab and you will get a 0 for that lab. So please follow the instructions for safety. Masks must be worn at all times, and goggles and lab coats must be worn at all times. And you must have the proper attire. If you do not have the proper attire, I will ask you to not conduct the lab at that day. And there are no makeup labs. So if you miss a lab, then you will get a 0. If this keeps happening, then I will have to bring this topic up with Dr. Look. So safety is very important. So please obey the laws of safety when you are in lab, okay? And then, like I said, no labs. There are no makeup labs anymore. And then mask coverings and plagiarism. Please, please, please do not plagiarize. If you plagiarize, I will find out, because I was once a student not that long time ago, so I know what plagiarism looks like. I'd rather you give me a bad report and tried it then give me a plagiarize. Because I've already seen that there are already websites of students who took in my class last semester and uploaded their information and how they did everything. I will know you got it from there. All right. And also Blackboard will tell me you have received it from there. So please do not plagiarize. Try your best and do the report. If it's bad and you tell me it's bad and you don't know it, I will give you a chance to redo it and then help you out. Try your best. Do not plagiarize, because plagiarism is not gonna, you're just wasting your time and you're wasting my time, and I will know if you plagiarize. Try your best, do it. If you need longer time for it, let me know. I'll give it to you. I'm also taking classes. I am also a student, so I understand that sometimes you need more time. It's fine. Totally understand it. Just do not plagiarize. Do not pay somebody to do it. Do not go on Google, find somebody. I know Corsical already has, some student already entered all the old lab reports. I don't even know. I already know who that student is for all those lab reports. So it's fine. I can't do nothing about that. But please do not copy and paste other reports. All right. I will know. Try your best. Hand it in. If it's bad, it's fine. I'll let you redo it. If it's good, then it's good. But do not plagiarize, please. All right. It's only gonna hurt you, and it's not gonna hurt me at all. It's just gonna hurt you. Okay. And that's just not for this, for any class. If you're out front with anything, then it's better than not doing it at all. Yes.
Professor, are you doing your PhD or your master's right now?
Oh, I'm finishing up the master's right now. So my expertise is actually in organic chemistry, not Gen Chem. But as a master's student, you must know Gen Chem. You must know physical chemistry at all. So hopefully next year I will do. Hopefully next year I will start my PhD. But at this moment,
Okay, so you want to be a professor, like a full-time professor afterward?
Tell the truth, I don't want to actually. So when you get your PhD, right? For anybody who are willing to get your PhD, you have a myriad of options. Somebody who has a PhD really has two options: either go into academics, or go into pharmaceutical, or even go into governmental. The tenure track professors at Queens College mostly focus on research, right? They're obligated to teach a course in this college as part of their agreement. Most of the tenured professors in the school only focus on research. That's why they have specific office hours. They have this, so it's hard. You don't really have to. You don't really have to teach when you actually get a PhD. You're more a research-based person. There are PhDs who actually solely got their degree on teaching, and they're some of the best people. But as a scientist, we focus more on the research part than actually the teaching part, and that goes for any university you go to, private or public. Okay.
Yes, understood.
All right, so going back to, so this is the schedule of, this schedule will not change. So this schedule, it does say in person. Some of them we're gonna change it to online, but the schedule is still the same. So today we're doing boiling points. Next week we're gonna do the iron content, and then this schedule is the same. Okay, so we're not changing the schedule at the moment. And then, like I said, no plagiarism. If there's something I don't know, please, you can email me, or, and I'll email you. And if I can't answer, I'll let Dr. Lick know. And recordings, I'll always record these lectures. I might forget to upload them, but you can remind me and I'll upload them on Blackboard, okay? So next week we don't. Okay, Serena. So next week we don't have class, yes. But the week after, I don't know. If you don't get an announcement for me saying that the labs will be in person, they will be online. Okay? So if I don't send out an announcement saying the next week lab will be in person, then it will be online. Okay? Just wait for the announcement. If there is no announcement, then it's online. If there is an announcement, then it's in person. Okay? Just read the when I send an announcement, just read it carefully to know if it's online or in person. I'll just remind you guys through the announcements. All right. Okay, so that is the syllabus. Any questions regarding the syllabus before we move on to the next topic? Please don't be shy. Just come on. If you guys have a question, it's
Professor, I
very
have a
clear right now.
question.
Go ahead.
I have a question. So we don't see you September 7th. We don't do the lab, or we still do a lab for that day?
What do you think? If you don't see me, do you think you have to
I
do
don't
the lab? Hello? Anybody there?
I don't know.
Come on. If I'm
We
not,
don't have lab for that day. It's
you
like
don't
we
have
have,
class, so you don't have class in general that day, right? Monday, Tuesday, and Wednesday, you don't have class at all. So how are you gonna do the lab that day? Right? If you don't have
it's like if we had class in person and we didn't have to go that week, that means we didn't have to do anything in class that week. So same thing in online.
if you don't have class, how are you gonna do the lab? Tell me, please. Right? You guys don't have courses at all next week, Monday, Tuesday, and Wednesday, right? Unless you're referring to, do you have to hand in a lab? If you don't have to you don't have to hand in a lab next week Tuesday, because you will hand it in on the 13th, like Matthew explained. But there are no classes on Tuesday, so we can't really come. I can't force you guys to come to campus and do a lab because the stock room will be closed. And I actually don't want to force you guys to come to campus and do a lab, because that's just more work for me to force you guys to come to campus and do a lab. All right. It's due on the when is the 2 Tuesdays from now? It's the 14th. So it's due on the 14th at 11:59 p.m. Okay. Also, who was asking that question about do we have lab next week? Do you understand? Did you get the answer to that? Yes, so the first lab report is due on the 14th. Yes. Yes, first lab report is due on the 14th. If you want to hand it in earlier, that's totally fine with me. I have no problem. The faster you get done with it, the faster you get done with it, right? But the official deadline for the first lab is on the 14th. So I will upload, I will have the assignments, the assignment folder ready for you to upload by this weekend. And if you want to hand it in early, you hand it in early. And if you want to wait until the 14th, then you can wait until the 14th to hand it in. All right? Any questions?
Professor, I was wondering, even if we go back in person, instead of printing out the lab and giving it to you in person, can we email it to you, since you said that we have until like midnight to submit, right?
I did say that, right? I did say that.
So yeah, it invalidates if
You're
you
right.
ask us to bring it in
You got
class.
me there. You got me there. So when we start in person, you will have to hand it in to me that day. Okay? You can't email it.
Professor, you can't change it now.
I did
You
say
already
that.
said it. It's
No,
done.
I can't change it. That's what makes
But
it.
it's like, it's kind of inconvenient to like print
I know.
it, because
know.
some of us, I am not used to going in college for 2 years now, and it's like, I feel like I don't want to be late to class, and that's an extra headache. So can't we just take our time and just submit it to you by email?
I mean, look, here's the thing. The class ends at 10:30, right? So it's technically close to 12. So technically, you're still handing it in on time. You still have to,
So if we can bring it, then we can just give it to you. But if by any chance we couldn't bring it, we could just email it to you, right?
No.
Can't we just do that, Professor?
This is Dr. Luke's, this is the lab coordinator. This is what he wants. So I will have to, abide by that at least. So if you finish the experiment early, then you get to leave early. If you need the whole time, then you need the whole time. That is solely up to you. So if you do the pre-lab very well, then you should have no problem leaving early. Yes, as long as it takes. So if you do the pre-lab well and you understood well, then it shouldn't. That's the whole purpose of the pre-lab, that you read the lab manual well, and then you were prepared, you did your experiment, and you left. It's an efficiency. It helps with time and speed that you need, and also for safety, because you know what your chemicals you're dealing with. So that's why the pre-lab is very important when we start doing in-person labs. So up until now, then it'll be due midnight, but once we actually start, then it'll be due manually. But like I said, let's say that you guys have an exam that week. I will push it off to maybe the next week. You'll have to hand in 2 labs the next week. All right? That is the best thing I could do for you guys. But there will be no emailing once we start actual experiments. Okay? That is the best I could do for you guys. And if you guys need extra time and there's something emergency come that you guys need extra time, you're free to email me and then you have extra time. But I will be collecting it in person once we actually start getting back in person. Okay? Whoever brought that up, you almost got me, but no. All right, any other questions about the lab, pre-lab, or anything syllabus-wise or course-wise before you move on to the first? Oh, and we also have to see the video. So the video is about 45 minutes long. And then we'll start with the thing.
Just to confirm, the pre-lab is just abstract, introduction, and procedure.
Yes, abstract, introduction, and procedure, yes. Give me 1 second. Somebody just emailed me something. So Cindy, yes, you could buy this notebook. It's totally fine. Okay.
Thank you.
No problem. And how many students plan on actually taking Orgo 1 and Orgo 2 next semester? I mean, Orgo 1, because you guys can't take the Orgo 2. So you could use the same lab notebook you have now for Orgo 1 lab. It's totally fine, okay? So you don't have to go out and buy a new lab notebook for Orgo 1. You can use the same notebook for Orgo 1 and Orgo 2. All right, because I teach Orgo 2 this semester, and I told them the same thing. If you guys have this notebook from previous, you guys can reuse that, okay? Okay, you're taking, yeah, so basic, yeah. I think you use the same lab notebook. If you buy this lab notebook, then you could take the same one. So why are you taking basic, Orgo, and Gen? You know what? It's fine. Don't worry about it. It's fine. Because Gen Chem this Gen Chem 2 is harder than basic Orgo. That's your course. All right. Any other questions, guys?
You're only saying that because you like organic chemistry.
Yeah, I mean, of course. What am
But
I?
you said it's easier. It's not really.
What's not easier?
You said basic organic chemistry is easier than general chemistry.
It's supposed to be easier.
That's why I said it
It's supposed
depends.
to
You're
be.
more, that is more of what you like and understand. So it will be different for you.
Yes, I am biased in that opinion. You are right. But I'm biased. What can I say? All right, and I don't know about teaching organic chemistry next semester. I have no idea. That is still up in the air. But in all honesty, basic Orgo, it's if you're take general chemistry 1, it's a general chemistry 1 and 2, Orgo 1 and 2 are a lot harder than basic organic chemistry 101 and 102 when it comes to the amount of studying and the amount of course-wise. So if you're taking general chemistry 2 and you're taking Orgo basic organic chemistry, you'll see the level in difficulty between general chemistry 1, general chemistry 2, and basic Orgo. you'll see that you're developing more, even though it's organic chemistry, you'll see that you're developing more time for general chemistry too. Not because not that I'm biased, but general chemistry too requires more time because it is what do you call it? How do I say it? It is a degree level class. It's what students who are getting students who are taking biology and chemistry majors, this is what you guys need. So it's 101 and 102 are designed for people who do not want to go into chemistry but just need some science in them for them to graduate. So that's designed for those students who are not really good in chemistry. If you're taking general chemistry too, that means you want to go on to, chemistry related stuff, like PA, OT, DO, MChem, anything those type. So that's why you're taking general chemistry 1 and 2. Or if you're into physics majors must take general chemistry 1 and 2. They don't have to take OGO, but they have to take general chemistry 1 and 2. And if you're a math major, you also have to take general chemistry 1 or physics 1 or general chemistry 2 or physics 2. So chemistry 1 and 2 are harder than basic chem and basic orgo. I'm not saying basic chem and basic orgo are hard or easy, sorry, but the level of general chemistry 1 and 2, they're not the same.
Yeah, I understand, because it's more like for general chemistry in general, because they're covering every single thing or sort of a lot more things rather than focusing on one stuff. So it's harder because there are more information, where if you were learning about organic chemistry, it's sort of like focused in one area.
General chemistry or 101 and 1 and 2 does not even scratch the surface that Gen Chem 1 and 2 go into, or OGO 1 and 2. It's just a tip of the iceberg, let's say, for a better lack of term, of chemistry. It's for students who want to just know the basics, be a good citizen, and just know the basic of chemistry for 101 and 102. But general chemistry 1 and 2 are harder than should be harder for students, especially for students who don't want to get into any science related career. For students who want to not go into any science related career, general chemistry 1 and 2 are harder than 101 and 102 in Queens College. Can't say that for all the colleges, but for this college, yes. All right, so let's go back to syllabus. All right, any questions regarding the syllabus or anything else, pre-lab wise or anything before we move on? No? Okay, so we'll move on to the lab. So have anyone taken has anyone looked at the lab manual so far? The first lab, the boiling points. Have you guys gone through the boiling points? Okay, that's okay. You guys are already starting off. Whoever said no, you guys are already starting off bad. Whoever said yes, you're already starting off good. Thumbs up. It's fine. If you skim it, it's fine. Okay. So let's look at it real quick. And then after this, then we will do the video, and then I think that will stop it for tonight. All right. We had 3 other classes. I wish I could help you there, but I can't. When I was an undergrad, I was taking 3 science classes at a time. And they were all chemistry courses. So I was a double major. I was bio and chemistry. So I finished up the bio degree, then I did the chemistry degree. So
Professor, did you take microbiome?
Did I take microbiome? Yes.
How was it?
It was it wasn't easy, but it was interesting. Just want to tell you, I'm not good at bio. I got the degree, but not really good at bio. but I'm more of a chemist. My concentration is more on chemistry.
It's just I just had my first class today and it was
What do you
a
have
bit
into lab instructor?
scary. For lab, let me see.
Is her
I
name
have
Jacqueline Sarmiento?
let me take a look. Give me one moment.
If anyone is taking microbiome and that's your lab instructor, Jacqueline Sarmiento, just tell her you have me as a lab instructor too, okay? Ah, okay, good. So you have Jack, oh. Do the Chem 2 lab action. In all honesty, it takes at least 2.5 hours. It may not take the full 3 hours, but it might take 2.5, 3 hours. When I taught it last time, a lot of students came prepared. Actually, sorry, I take that back. One student came prepared, and a lot of students did not come prepared. And the students who did not come prepared, it took about 2.5 hours. Well, also, it only took them 2.5 hours because I helped them out. And since it was a smaller class size, I was able to do everything quickly. But it's full capacity, so I can't help everybody out. You will be on your own most of the time.
I have Professor Gregory Lalos.
Oh, I don't know who that is. But if you guys have Jacqueline Sarmiento, then
I don't think Professor Jacqueline isn't teaching the lab for 200.
no, for 200.
Well, maybe not for my professor because my lecturer is Professor Shima.
Chima, yeah, she's also teaching. Jacqueline is also teaching the class. One of the students have her actually. I just Mania, am I saying your name correctly? You have her, right? Oh, you're taking Bio 44. Oh, okay.
Yeah, for 200, I don't think her lab sections are offered for microbiome because all the lab section professors are listed and she's not teaching microbiome labs.
I thought she was teaching that. But okay, so Moina, you're taking Bio 44, so she's your lab instructor, I'm guessing, right? So just tell her you know me, and then can't help you get a good grade, but you could tell her you know me. We actually took I think me and her took one class together. That's why after that, she was a bio major mostly. All right. Stop getting me off track. Anybody else, any last question before we go on to the lab manual or the lab that we're supposed to do today? Any questions? Going once, twice, 2 times, 4 times? No, all right, there. Excuse me? Is it due? What do you mean due today? Nothing is due today whatsoever. Yeah, there can be, no, nothing is due today. All right. Exploring boiling points. So if you guys have the lab manual, I suggest you guys could look at it through your side. If not, I will have it open. Excuse me, sorry. All right, so exploring boiling points. What affects boiling points, what does not? We'll start off by, does anyone know the definition of boiling point? Have you guys gone through this in lecture yet?
Yeah, I know.
So yes?
It's at the temperature where an element's reach basically like the boiling point. It's pretty self-explanatory.
No, that's not it. Liquid to gas. Okay, there's a better definition than liquid to gas.
Is it the temperature where a liquid boils to vapor?
It's when the temperature of the liquid phase matches the temperature of the surrounding at 1 AMU, right? Right, that's what, yes, no, anybody, yes, no? It's when the vapor pressure of the liquid matches the vapor pressure of the atmosphere at 1 bar. Yes, no, anybody? please. Okay, I got 1 yes, 2 yes, 3 yes. All right, we'll take 3 yes. All right, majority rules. All right, so you guys are planning on taking organic chemistry, right? Or maybe some of you? Unfortunately. Okay, cool.
Yeah.
All right, so organic molecules are used in everyday life. Does anyone know the boiling point of water in Celsius, not in Fahrenheit? 100 degrees, yes. 100 degrees Celsius is the boiling point of water. What makes water have such a high boiling point? Because water is a universal solvent, right? But what makes it special? Why does water have such a high boiling point? Correct, hydrogen bonding. Water has something special called hydrogen bonding. Bonding is a very important thing when it comes to looking at chemical reactions or looking at intrinsic and extrinsic property. You guys know about intrinsic and extrinsic property of chemicals, right? You guys have learned that in general chemistry 1. What is an extrinsic property? What is an intrinsic property? Yes, no? Or am I jumping the gun and that's in general chemistry 2? Can anyone answer? Okay, I'll take that. Okay, just reviewing. So their boiling point, I believe, is an intrinsic property of compounds, right? It based on what type of compound it is and what type of bonding the compound has. So there are several criteria to what affects a compound boiling point. One is the type of bonding. Does anybody know what the boiling point of? So let's go to this. Methane is a very important gas in our nature. Without methane, we will have a lot of things. Methane was one of the fundamental compounds needed for life to evolve and to have reducing atmospheres, as you will learn in future classes. But methane is what? A gas at room temperature, right? Can somebody tell me, look up right now, what is the boiling point of methane? In Celsius, not in Kelvin. No, it can't be 161 degrees Celsius. No. You said minus 161 degrees Celsius? Yes, negative 160, 182. Which one is it, guys? 182 or 162? Which one? Because I don't know. I know it's a negative number. All right, let's 162. It's negative.
161 degrees Celsius, negative 161.
Yes. So the most important thing is negative. It's negative 161 degrees Celsius. So what does that mean? That means methane cannot be a liquid or a solid. Methane must be a gas. So methane can only be found as a gas. But I want you guys to now look at methanol. I'll type that in for you. Methanol. Somebody look up what the boiling point of methanol is. And tell me what the boiling point of methanol is. 64 degrees. Almost 65 degrees, right? So what is the difference between the boiling point of methanol and the boiling point of methane? So almost at 100 degrees Celsius, right? Almost, no, more than that. It's almost 200 degrees Celsius, right? So that means, what's the difference chemically in methanol and methane, right? Methane is CH4, right? Methanol is CH3OH. What is the difference between methane and methanol? What is the key difference? Not just oxygen. What does it have that's similar to water?
Hydrogen bonds.
Perfect. Whoever said that, you are right. Hydrogen bonding. That hydrogen bonding has increased the extrinsic property of methane from methane to methanol 200 times. That's how important hydrogen bonding is when it comes to boiling points. Hydrogen bonding increases boiling points drastically. Okay, so when you look at this lab, you could explain some of your molecules might have hydrogen bonding, some of them might not, but one important factor is hydrogen bonding. So in your introduction, you will have to explain what factors play an important role in hydrogen bonding and what factors don't. So we already know one factor, hydrogen bonding. What is another factor in boiling points? Intermolecular, yes. Intermolecular compounds. So if there is if let's say in not inter, but let's say van der Waals repulsion, right? You guys know about van der Waals forces, right? That's one thing they teach you in chemistry. So you have London dispersion, van der Waals, and then you have what do you call it? Hydrogen bonding, right? The most important is hydrogen bonding. Then you have van der Waals, and then you have London dispersion. London dispersion is an electrostatic force. Van der Waals is an interaction between the electron clouds, and hydrogen bonding, as we explored, are between compounds like oxygen and hydrogen, or nitrogen and hydrogen. Those are the three types of forces, three types of interactions in any chemical reaction, and ionic bonds. But we're not going to look at ionic bonds right now, okay? Because ionic bonds, anyone know a compound that's ionic? Is used in everyday life. Yes, sodium chloride. Sodium chloride is what? Salt. What do you guys think the boiling point of sodium chloride is to make it into a liquid? Somebody could Google it real quick. What is the boiling point of sodium chloride? 600 degrees what, Celsius or Fahrenheit?
It's 600, and isn't it 800 degrees Celsius?
Okay, so NaCl is a salt, right? To make it into liquid is going to take you 600 degrees, whatever, it's Fahrenheit or Celsius. And then from liquid to gas, what is the temperature? What is the boiling point? Yes. So we're not really looking at NaCl as, we're not looking at ionic bonds when we're talking about boiling points. Okay, so when you look at ionic molecules, we're not looking at boiling points. Okay? Everybody understands? Right? So ionic, cool. Ionic bonds are not looked at when we're looking at boiling points. We're only looking at covalent bonding. Okay? So you have ionic bonding and you have covalent bonding. You guys learned this in general chemistry, right? The two types of bonding, ionic and covalent. Right? Ionic is NaCl, and covalent is everything else. Right? You have polar covalent, non-polar covalent. Correct? In methanol, right? So you have methane and you have methanol. Which one is polar covalent? Which one is covalent? Yes, I'm gonna think you're probably writing methane. Yes, methane is covalent. That means methanol has to be what? It's fine, don't worry, I know. And then methane has to be what? Polar covalent. Good. So you got, good job. You guys remembered your general chemistry 1 material. So methane is polar covalent and methane is covalent. Yes. So we see that having a polar group there increases boiling point, right? So if you have a polar group, then you must have a what? What is polar covalent? So polar covalent is when there is bonding between two compounds that have vastly different electronegativities. Oxygen has an electronegativity of, I believe, 3 point something, and hydrogen has an electronegativity of something like around 1. So when you have two compounds that have two different electronegativities, but they're not ionic, then that's what we call polar covalent. And ionic is when you have two compounds that have very drastic electronegativities, and I believe the negative, if it's above 2.7, the difference is 2.7 or greater. Sorry, 1.7 or greater is ionic. Anything 1.7-ish is polar, and anything below that, then it's just covalent. I don't know this, I forgot the specific numbers, but that's You guys can look it up what the specific numbers are when it comes to what's considered polar covalent, covalent, and or you could think of as metal and non-metal or ion. Yes, but there are some metals who are transition metal, who are semi-metals, and then you could form bonds with them. So, you know, they're not really thing. You can't really consider them as real metals. But the difference is just that number. No, you're right. There are a lot of metal and non-metals will create ionic bonds because they're salts, like sodium bromide, sodium chloride, potassium iodide, all that. You're right about that. But there are some metals that form with non-metal that are not really ionic. Okay, because the electronegativity, if you recall it, if it's not within that margin, within those differences, they're not really considered ionic or covalent. Okay, does that answer your question? I don't know who asked that question. Serena, does that answer your question?
Yeah, thank you.
No problem. Okay, so going back, so somebody review. We have London dispersion, we have van der Waals, and we have hydrogen bonding. So far, we know hydrogen bonding plays a vital role in boiling point. Now, for organic compounds, is also very similar. Also, we see that organic compounds, when you increase a chain, right, you also increasing the surface area. So compounds that have a big surface area, right, also have high boiling points. Do you guys understand that? So compounds that have high surface area have higher boiling points than compounds that don't have surface area. Okay, let me show you guys real quick. This is a quick Orgo lesson, so if you don't understand it, that's fine. It's not really, okay. Let's take this, right? This is 1, 2, 3, 4, 5. This is pentane, right? Pentane has an electron density represented by this, right? Can you guys see the drawing or no? All right. Okay.
Yeah.
So this little bubble that I drew is the electron density of pentane, right? Now pentane can also be drawn this way. 1, 2, 3, 4, 5. This is also pentane. It's and we refer to this as a constitutional isomer. You will learn later on, but this is also called pentane. Its specific name is called neopentane, but it's also a pentane molecule because it has 5 carbons on it. But the electron density of this compound actually like this. Which one has a greater surface area? 1 or 2?
One.
What? Yes. 1 has a greater surface area. So 1 will have a bigger, a higher boiling point than neopentane. So you guys could Google it. You guys could Google what is the boiling point of pentane, what is the boiling point of neopentane. And you'll see the vast difference in the boiling points of pentane and neopentane. What also contributes to this is that you guys learned about van der Waals, right? Dipole-dipole interaction. So when you have compounds, when you have a lot of pentane molecules, right, they could induce a dipole within them, right? This compound can induce a dipole with them, which you'll also have some electrostatic reaction where the positive charges all line up on one side and negative charges line up on another side, causing an electrostatic attraction, making the boiling point increase. So the greater electrostatic interaction, the greater the boiling point. The lower the electrostatic interaction, the lower the boiling point. So van der Waals interactions are important when you're talking about surface area. So surface area plays a key part in van der Waals interaction, and also a part in increasing the boiling point of the compound. So we know that boiling points are affected by hydrogen bonding. We know that boiling points are also affected by van der Waals interaction through dipole-dipole, and also through surface area. Okay? Anyone needs me to clarify those points? If you need, that's totally fine. Please let me know now. Okay. What do you want me to repeat? So you know, Malika, you know about the hydrogen bonding, right? So if you have hydrogen bonding, you automatically increase the boiling point of a compound, right? So that, I don't think there should be any confusion in that, right, Malika? Cool. Now we're looking at surface area. Surface area is also part of van der Waals, right? So do you know what, I'm gonna think you know what van der Waals interactions are, right? It's just interactions between the electron cloud of certain compounds. Okay, you understand that, right? Yes, go ahead, answer your question. I mean, I saw you raise your hand. Okay, so van der Waals interaction is between the electron density. So when two molecules, right, meet, there can be a certain dipole-dipole interaction. Not dipole, but there can be a change in the electron cloud where for some reason, right, there's a partial positive and partial negative charge, right? They're mimicking ionic compounds. They're not ionic, but they're mimicking ionic compounds, increasing the boiling point of them, meaning that they're close to each other, so they're increasing the boiling point. Okay? So that is what this this is what this property is. So compounds that have higher surface area have a lot more spaces where this short dipole can interact. This short positive and negative charge can interact, and causing the boiling points to increase. Okay, Malika? All right. Okay, so we learned about, and the next one is an electrostatic interaction, which is learned in this third, right? It's if there is slight electrostatic interaction between compounds, they will also increase the boiling point. Now we look at compounds that have halogens, right? Chlorine, fluorine, bromine, and iodine, right? Compounds that have that, where it is hard, where the so compounds that have fluorine have, or compounds that have higher electronegativity, those compounds have a higher boiling point, or sorry, not higher boiling point, lower boiling point, because those electrostatic interactions, right, are making the compounds repel each other. Compounds that have bromine or iodine, well, just halogens in general. Sorry, let me rephrase that. Compounds that have halogens in general will have lower boiling points than compounds that don't, because of the electron density. Those electron density will be repelling themselves, making them have a higher boiling point. Okay? So compounds that have halogens will have a tendency to have lower boiling points. All right? So that's basically it for this. So now let's talk about the lab itself, right? Okay, so for the lab, what you guys will be doing, so you guys, this chart, you will have to copy and paste it on your lab manual, right? So this is your data. So you see it and you see these chemical formulas. You will have to graph these data sets like this. So first you do is graph these data sets, right? Once you graph it, you get this straight line. Okay? Once you have the straight line, right, you can also fit this curve to match the lines. So as you can see here, it's really not a straight line. It's more like a parabola, right? So you could fit, yes. So you will copy this data right here. Cynthia, or am I saying your name correctly? Okay. So this data, just copy and paste onto your lab manual, okay? So everyone knows this data, you could just straightly copy and paste from the lab manual and put it on your data sheet, right? All right. So once you have that, right, you can, once you've copied and pasted this, yes, so you graph exactly what the lab manual tells you, right? So you have to graph the molar mass, which is given right here, to boiling points, right? Oh, so also I forgot to tell you this. So for organic molecules, right, when you increase the amount in carbons, it goes up about 10 to 14 degrees. So the more carbons you add to a straight chain alkane, it's hard to explain what a straight chain alkane is if you guys don't take orgo, but when you add extra carbon molecules like this, right? So a straight chain alkane is basically this. CH4 is 1 carbon. Then you're adding another CH3, that's 2 carbon. Then you add in 3 is propane, butane, so on and so forth. So that's what we call a straight chain alkane, right? There is no branching. So there is no, like this carbon could have, you know, let's say you have, you guys don't know what this is, but this is 1, 2, 3, 4. This is butane. It has 4 carbons, and it's we consider this a straight chain, right? You could also have branching like this, like this, like this, right? So straight chain, this is called a branched alkane. A straight chain is alkane without any branching. It's just like that. They call it straight chain, but it's a zigzag. What can I say? That's orgo for you. Okay. So if you look at the data, it tells you to molar mass is on the x-axis and boiling points is on the y-axis. So you graph the data set, and then you get this get these points. These points actually don't fit a straight line. What they actually fit is there's something like a parabola, right? Not a parabola, but an exponential, something exponential, right? So if you keep adding straight chain alkanes, you see that actually keep going. You're adding about 10 to 14 degrees more. So molar mass has some type of influence in boiling point, right? In a straight chain alkane. What we're doing is that we want to see how other compounds fit this trend line. So you will be given a data set, which is here, and you will fit these onto this graph of the original straight chain alkane and see where these molecules fit in this, right? Once you have fit this, right, what you have to do is you go onto this website, NIST, right, NIST, there you go, right? You go onto this website, procedure, charts below, you go onto the website, wbook.nist.gov, right? You look up these molecules, right? And it will tell you what you need. It will give you the boiling point, it'll give you the molecular weight, it'll give you all the information. And what you need to do is you need to graph the boiling, right? If you see this graph, you need to graph the molar mass and the boiling point of your compounds, right? So you will essentially have 3 graphs. One is the straight chain one, where it's not showing as a parabola. Second one is the one that's showing as a parabola. And the third one is where you have your compounds listed. Okay? And once you see that, right, you see where your compounds are, that's all you have to do for the graphing. And after that, in your discussion, you will explain why you think those molecules are where they are. What's influencing them? What's influencing their boiling point? Okay, where are you confused at? Zuraya, am I pronouncing your name correctly? Okay.
It's Zuairia.
Zuairia, sorry about that. So you know you have to graph this, right? So you have to graph this data set. Your x-axis will have the molar mass, and the y-axis will have boiling points in Kelvin, right? So you get that part, right? So this data is
Yes.
represented by this graph and this graph, okay? Right?
Okay.
So the difference between this graph and this graph is the trend line. So this line here is what we consider a trend line. This line here is what we consider a trend line, okay? So this trend line, if you make it straight, it doesn't really fit the dots correctly, right? So instead, we use something called the best fit curve. And when we use that function, then we see that we get this trend line, okay? And these are the 2 graphs you'll have. So one that has a straight trend line and one that has a best fit trend line. And both these are coming from that one data set that's given in the lab. This data set here, okay?
Okay.
All right. So then once you have that data set, right? Then I will assign you guys one of these desk numbers. The desk numbers correspond to the compound over here. So you will look up these compounds in this website right here, right? You will search the name of the compound. The website will give you the molar mass and the boiling point of the compounds in Kelvin, right? So what you would do is once you go to the website, right? You press search box, you press the name of the compound, enter the compound, then you press phase change, right? And it'll give you the molecular weight, and they'll give you the structure of the compound, right? And then give you the boiling point. So on your lab report, you must show the structure of the compound, you must show the boiling point and the molecular weight, okay? All right, guys?
Professor, is it just going to be on the graph, or do we have to make a table or something for that?
So no, you have to make a, if you want to make a table for that, that's fine. And you could make a table for the compounds you have listed here. But if you want to handwrite it and upload it, that's also fine. So you could handwrite the molecular weight, the structure, and the boiling point of the compound assigned to you. Or if you want to do it on computer, you could do it on the computer too. It is fine. It doesn't matter how you do it. I just want to see that you have the structure of the compound, the name of the compound, the boiling point, and the molecular weight of the compound. Okay?
Okay, thank you.
Yeah, so once you've looked up the compounds and all that info, right? Now you will add that information to this graph. So once you've made this graph, right? You could add that, so then you have to add those points onto this graph. When you do Excel, you're able to add those points onto this graph and make them a different color, right? And this lab manual tells you how to do those different colors. Just read through that carefully and it'll tell you how to exactly change the colors of it. And if you can't change the color of it, just when you're doing it, just point at, oh, this is 1, this is 2, this is 3, this is 4. And then somewhere on the bottom of the graph, you say 1 is this compound, 2 is this compound, 3 is this compound. If you're unable to follow the lab manual on how to do that, okay? So either way is fine.
Sorry, so there's 3 graphs, right? So the one,
so I'll make it easy for you guys. There's 2 graphs, okay? You'll have 2 graphs. One is this graph here, right? 2 is this graph here, right? And on this graph, you can add the data sets for this, okay? You guys.
the data set for the compounds from the desk thing?
Yes.
Oh, okay.
Okay. All right. And those data sets, you can make them a different color, and the manual tells you how you can make a different color. Okay. And if you don't know how to make a different color, you see how this person labeled in this, you see how they labeled A, B, C, right? Somewhere on the bottom of the graph, you can say A is this molecule, B is this molecule, C is this molecule. Okay. All right. So once you have graphed that, then the graphing is done. So there's 2 graphs with all this. So you would have the straight chain alkane, then you have the points that represent the 5 compounds you have. And then in the discussion is very important. In the discussion is where you explain why do you think those molecules fit the trend line or don't fit the trend line. Okay. And this is where most of the points will be. Your graph will be, so if I was grading this, you know the 50 points is automatically going to formatting. 30 points belong to the graphing correctly, and 20 points belong to your explanation of why you think these compounds are not following trend line or why they're following the trend line. And also within that 20 points is in your introduction, you're explaining everything about London dispersion, hydrogen bonding, and van der Waals. Okay, and that's all you have to do for the lab. Okay, so that's basically will and that's it you have to do for the lab. So I will assign you guys the datas right now, okay? Give me 1 second, let me just pull up the roster. So does anyone have any questions? No question? Okay. Give me 1 second, sorry.
I have a question.
Yeah,
So
go
we're
ahead.
gonna use copy and paste the data that is given in the lab, and then on top of that, we're gonna add on those extra compounds that you're assigning us.
Exactly, perfect, yep. So first you will copy the data set that's already there, right? The table, and then the graph that's already, so the graph you don't copy and paste. The graph you actually have to make yourself using the information, and then you have to input the compound lists you have onto that data, okay?
Got it.
Okay, so, oh, I forgot to, giving you guys the data that you guys need to use, right? Sorry, give me 1 second. Yes, and you guys could email me anytime if you guys need help. It's not, I'm always open for emails, okay? And when I email you guys to it, it'll be the email that's on your Blackboard, okay? That's registered to your CUNY First account. That's the email that I will send emails to you guys for. So if you guys need to update that, please update that. And we still have to see the video. Come on, CUNY First. Why does it keep logging me out? That makes no sense. Log in. CUNY First. All right, let's see who's, I'll just give you guys according to,
Is it the lab safety video we're watching?
yes. Where do we exactly upload the lab report? The lab report, there will be in under assignments in Blackboard. You guys could just upload it there, okay? So I'll have lab 1 assignment. That's where you upload it, okay? So I'll just give you guys the desk numbers right now. Okay, so Alexander, your desk number will be number 130, okay? Alexander, just say yes or type in yes in the text box so I know that you understand.
Sorry, do you mean Alexandra?
I'm sorry, Alexander.
Is there, okay, what did you say, 130?
Yes, 130, okay?
Okay, thanks.
Yep. Eliza, am I saying your name correctly? Please correct me if I'm not. Eliza, are you there? Do you check yes? Yes.
Yeah.
Okay, sorry. Your desk number will be 131, okay? Ashley, your desk number will be 133. Okay. Brooke, you're 134. Christine, you are 135. Cindy, you are 136. Cynthia, you are 137. Jasmine, you are 138. Jason, you are 139. Christina, you are 138. No, sorry, 140. Lakshita, you are 141. Malaika, you are 142. Matthew, you are 143. Monia, you are 144. Samantha, you are 145. Sejla, you are 146. Serena, you are 147. Charmin, you are 148. Shira, you are 149. Suleiman, you are 150. And Zuaria, you are 152.
Thank you, Professor.
Anyone does not know the number? So you guys, so these are your desk numbers. So these are the information you will use for your report, okay?
Thank you.
So if no other questions, we'll start the safety video.
I'm looking at the lab outline and,
Okay.
and where do I see the desk number?
Desk number, if you go to the manual, it's right, it should be on page, sorry, I just closed out the manual. Give me 1 second, sorry guys. So on the manual, the desk number is on page 4. So
It just says a procedure and
yeah, so the procedure you see on is right there. You see the desk number, right? Right next to the desk number, it has compound numbers, right? So what number are you?
143.
So 143. So you have to look at compound 6, 14, 19, 20, and 25. So if you look at the column on the right hand side, compound 6 is 1-hexene. Compound 14 is 2,2-dimethylbutane. Compound 19 is 2-propanol. Compound 20 is 3-methylnonane. And compound 25 is dimethyl ether. So you would look up these compounds on the NIST website, find out the structure of it, find out the boiling point and the molecular weight of these compounds, and you would put them in a chart, and then you would graph the molecular weight and the boiling point onto the graph. Okay?
Got it. I got it.
And also be careful. Some of you guys have butene, heptene, heptine, hexene, octene. Make sure you do not mix up heptene and heptane. Heptene and heptane are two different compounds. One of them is an alkene. One of them is a straight chain alkane. So make sure you have the correct spelling, okay? Because if you don't have the correct spelling, you'll get different results. So make sure the spelling is correct for all these compounds. All right? We're all good? Say it again. Who says no? You're not, somebody's not all good.
Professor,
Yeah.
I'm kind of confused because it says data set number, not desk number.
That's whoever. Who's the data set number? Where does it say that?
On page 4, where it says procedure, it says data set on the lab manual.
Is okay. Data. That's what it says.
Yeah, and then it's like listed 1 through 27, and then the compound number is 1 through 32.
They must have changed it. Hold on, let me check.
Yeah, that's what I was that's what I was asking about. That because I didn't see the desk numbers.
Got you. So I guess they changed the thing from last semester. All right, hold on 1 second. But it should be the same, honestly. If I could ever log into Blackboard. Okay, there you go. Course material. Sorry about that, guys. I didn't know that. They did change data set number. That manual. Boiling points. Oh, data. Is it? Okay. So why didn't you guys? So I was saying these numbers and nobody was saying anything. So you guys all just went along with these made up numbers: 143, 144, 145. That's how I know you guys are not paying
Well,
attention.
it's you also said desk number, so I thought maybe we would be assigned to a specific desk once we go back in person, but
Who's
it's
that? Oh my God! You guys were all saying yes. This is horrible. Oh my God! It's gonna be a long semester. Who's the one that just pointed that out to me?
Me?
No,
Well,
it wasn't you. It was somebody else.
I kind of brought it up.
What, Matthew?
Well, I said, I don't know. We both did.
You know
Yeah,
what?
we
You're the only
both
one
did.
listening, Matthew. So I'll take that into mind when I'm grading.
Well, we know what we both did.
What happened? No, you guys are already okay. Oh, we have to do this again. Oh,
The chat was also going off, so I guess we all did.
no, you guys horrible. You guys horrible. Instructors make mistakes, guys. I didn't believe they actually changed these wording around. All right, let me reassign them. All right. Okay. Please, if you guys don't know anything, say it beforehand. All right, let's do this again. Okay. Ready? Alexandra, number 1. Yes? Okay. Eliza, number 2. Ashley, number 3. Brooke, number 4. Christine, number 5. Cindy, number 6. Cynthia, number 7. Jasmine, number 8. Jason, number 9. Christina, number 10. Lakshita, number 11. Malika, number 12. Matthew, number 13. Moina, number 14. Samantha, number 15. Tesla, number 16. Serena, number 17. Charmin, number 18. Shira, number 19. Suleiman, number 20. And Zuaira, number 21. All right. Everyone got that, right? Please say yes.
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 Anybody did
Yes,
not
we
get
got
that?
it.
All right. Any other mistakes before we move on, guys, from me? We're good?
Yes, we're good.
All right, we're good. Now, finally, we can start this video. All right, let's start this video. Okay. Okay, 36 minutes. Oh. Everybody can hear the
It's
video?
inevitable. In the laboratory. Accidents, by definition.
Yes? All right, perfect, cool. Let me know anytime you guys can't hear the video, okay?
Are unforeseen, but your knowledge of lab safety will help minimize the likelihood of accidents. And in this lesson, we'll talk about safety equipment found in the lab. These items may help you save a life if and when an accident occurs. When working in a lab for the first time, Look around and identify the location of the safety equipment. Every lab must contain a safety shower and eye washing station. Both should be tested weekly to ensure their work.
Sorry, wrong video. We'll do this again. Wrong video. Is this the one? Which one is it? I think this is the one. Let's check if this is the one. Oh no, this is the one. ACS safety 1991 video. Everybody can hear the video?
Yes.
Wait, we don't hear it anymore.
Professor, if you mute, we can't hear it.
Oh, you guys can't hear it? Okay. Sorry. How about now? Yes?
Yes.
Okay.
Chemistry lab is different from most other courses. Here you gain new knowledge by doing things, not just reading about them. You'll spend much of your time in chemistry lab working with equipment and techniques that are new to you. They can be dangerous if you don't adhere to strict safety procedures. But if you start with safety by following the rules, paying attention, and using common sense, you can work with confidence that you'll be safe in the chemistry laboratory. And you can have fun at the same time. Handling chemicals safely means following rules designed to keep them from contacting your skin and eyes or someone else's. One important safety rule is always use small containers that you can control easily. Ignoring this rule can cause accidents. If you have an accident, always inform your teacher. Pouring from small containers is far safer. Accidents can also happen when mixing chemicals.
Is this okay? Looks fine. You can go ahead and get started. Thank you.
To be safe, only mix chemicals when your teacher says to. Read the instructions for the experiment all the way through first, before doing anything. Read and reread labels before use to make sure you've got the right chemicals. Note the concentration and the hazard warning. Accidents can happen when the wrong chemicals are mixed together, or when the right chemicals are mixed together in the wrong way. Make sure to follow your instructions exactly. For example, suppose you have to dilute concentrated sulfuric acid with water. You might think you could mix them together any way you wish. But there's an important rule for diluting concentrated sulfuric or phosphoric acid that should always be followed. Add the acid to the water, never the reverse.
So the reason why they add acid to water, would anyone like to take a guess why? Anyone? No, not diluted. Safety think about safety. Why do we add acid? Yes, Serena is correct. So acid does not splash out. So when you add, so think about when you're dropping a rock onto water, right? What's the first thing that happens? It splashes, right? But what splashes? The water. It's the same concept when adding acid to water. If for some reason, let's say accidentally you drop a lot of acid, the thing that's gonna spill out will be water instead of the acid. Okay, so that's why we add acid, not we add acid to water and not the other way around. Okay.
Written by the initials AA, add acid. Watch what happens when you don't follow this rule. This is water added to acid. The acid boils, and it can splash out of the beaker. When acid and water are mixed correctly, there's less danger. Acid is poured from a graduated cylinder or beaker down a stirring rod into the water. Whenever you work with chemicals, there's a chance of spills. A work tray under your setup will help contain them. Always move carefully when handling chemicals. Keep coin top stoppers between your fingers, not on the bench where they can pick up contaminants. Hold bottles with your hand over the label and replace stoppers immediately. Covering the label keeps drips from blurring it or getting on your hands. Set bottles out of the way when you're finished so they won't get knocked to the floor. When handling chemicals, always keep them away from your face. Never taste anything to see what it is, and don't touch it or smell it directly from the bottle either. Small amounts of some chemicals, even vapors, can harm your eyes, mouth, and nasal membranes. There's a safe way to smell a chemical indirectly, if your teacher gives you permission. Hold it away from your face and waft the vapors to your nose. That way you won't get a strong whiff of them directly. Certain chemicals give off vapors. They're called volatile chemicals. You should work with harmful volatiles under a fume hood. Your teacher will tell you what these chemicals are. Chemicals should be kept pure and uncontaminated. One way to prevent contamination is to use only clean glassware. Another way is to only pour out of a reagent bottle. Never pour anything back in, even excess chemicals you haven't used. It's better to waste the excess than to risk contaminating the entire bottle with particles from around the lab. After measuring out a reagent, you'll often have something left over. Instead of pouring it back in the reagent bottle, dispose of it in the proper waste container. When drawing out chemicals with a pipette, don't use your mouth. Use a bulb or pipetter. You can collect the exact amount you need and never have to come in contact with it. At some point in your laboratory work, you'll probably spill something. You should report spills immediately. Stay away from the spilled chemical and let your teacher clean it up. To keep a large spill from spreading, it's barricaded with an absorbent material such as kitty litter. It's then either mopped up or covered over completely with the absorbent. The absorbent and chemical can be swept up with a broom. What's done with the residue depends on the type of chemical it contains. Your lab should have a container for each type of waste. Don't throw waste chemicals down the sink unless your teacher says it's all right. Waste paper that's not contaminated by chemicals goes in a conventional trash can. And broken glassware goes into a separate container. The last chemical handling safety rule to keep in mind is to clean up when finished. Glassware should be thoroughly scrubbed and rinsed so it's as clean as possible for the next experiment. Liquid puddles or powders left behind on the lab bench can get on the next person's clothing or skin. Wipe them up thoroughly and throw the paper towels away in the proper container. And clean chemicals off your hands before leaving. There may be invisible chemical residues that could damage your skin or contaminate your food the next time you eat. Work with small containers. Mix chemicals only when your teacher says to. Read and reread chemical labels. Read instructions all the way through first. Use a work tray if your lab has them. Move carefully and deliberately when handling chemicals. Add concentrated sulfuric or phosphoric acid to water. Hold coin top stoppers between your fingers while pouring. Hold bottles with your hand over the label. Replace stoppers immediately. Keep chemicals away from your face. Work with harmful volatile chemicals under a hood. Keep chemicals as pure and uncontaminated as possible. Draw out chemicals with a pipette filler, never by mouth. Notify your teacher to clean up spills. Put waste in the proper container. Clean up when finished. The main heat source in most chemistry labs is the Bunsen burner. It produces an open gas flame burning at a high temperature. There's always the danger of an accident if it's not used properly. For example, it should never be used to heat volatile organic liquids that give off flammable vapors. These substances should be heated in a heating mantle or a steam bath in a hood. But for most other substances, a Bunsen burner is an ideal heat source when used properly. There are several types of Bunsen burners, but they all have the same basic parts. The gas comes from an outlet on the lab bench. A rubber hose fits over the tip and over a similar fitting on the Bunsen burner. Most burners have a valve at the bottom to control the flow of gas. Air inlets control the amount of oxygen in the flame. A wing top can be placed on the burner to spread the flame out. There are several important rules to follow to use a Bunsen burner safely. First, check the gas hose for cracks. If you see any, get a new hose. Make sure the hose fits securely on the gas valve and on the Bunsen burner. The gas valve at the bottom of the burner should be open. You can light a Bunsen burner with a striker or a match. Open the gas line valve and light the burner. If the flame's properly adjusted, you can place the burner under your setup. When using a match, strike it away from you. Turn the gas on after the match is burning. That way, gas won't escape while you're striking the match. Light the gas from the side so the match isn't blown out. A yellow flame is too cool. Opening the air holes lets in more oxygen for combustion. Adjust the bottom valve if the flame is too large or small. The flame should be blue with a lighter inner cone. The tip of the inner cone is the hottest part of the flame. If the flame begins to sputter or flare, turn the gas off immediately. Also turn the gas off immediately if the flame goes out. Unburned gas escaping into the room could ignite and cause an explosion. Even when the burner seems to be working properly, if you smell gas, turn it off. Cracks or stars in glassware are dangerous. They can break open when it's heated. So before you heat any glassware, check it carefully for cracks or stars. Flat-bottomed containers are normally heated on a wire screen on a ring stand. Erlenmeyer flasks and other narrow-necked containers should be secured to the stand with a clamp. Test tubes can be heated in a water bath. The water bath transfers heat slowly and evenly to the test tube and helps keep it from boiling over. You can also heat a test tube directly in the flame. Hold it at an angle while moving it back and forth to distribute the heat evenly. Aim it away from yourself and your neighbors in case it boils over. Only heat containers with openings. A boiling liquid changes to gas, which must be able to escape. Gas can't escape from a closed container, and the pressure that builds up can burst it. Be extra careful when working with heated equipment. Hold hot glassware in beaker tongs, never your hands. Remember that the wire screen and ring stand are also hot. If you don't have tongs, protect your hands with gloves designed for hot glassware. Keep them away from the flame. Handle everything as if it's hot if you've been using a Bunsen burner. Glass and metal look the same when hot as they do when they're cold. Heat volatile organics in a heating mantle or steam bath in a hood, not over a Bunsen burner. Check the gas hose for cracks. Make sure the hose fits securely on the gas valve and Bunsen burner fittings. Stand back from the burner while lighting it. Strike matches away from you. Turn on the gas after lighting the match. Turn the gas off immediately if the flame sputters, flares, or goes out, or if you smell gas. Check glassware for stars or cracks. Clamp narrow-necked containers to the ring stand. Move test tubes back and forth through the flame at an angle while heating. Don't heat closed containers. Hold hot glassware in beaker tongs or hot mitts. Thermometers are one of the most important tools in the chemistry laboratory. They're easy to use, but since they're usually made of glass, they have to be handled properly. One common misconception is that lab thermometers have to be shaken down like medical thermometers. Shaking is totally unnecessary, and it can be dangerous. The liquid inside can move freely up and down on its own without shaking. Some lab reactions take place at higher temperatures than an alcohol or mercury thermometer can stand. The temperature of oxidation in a Bunsen burner flame is around 600 degrees Celsius. That high a temperature will vaporize the liquid inside. The resulting pressure will break the glass. But most lab experiments are conducted at temperatures from 120 degrees Celsius down to minus 20 degrees. And for that range, either a mercury thermometer or an alcohol thermometer is suitable. No matter which type you use, always treat it carefully. When you're finished with it, set it down where it will be safe. Lay it away from the edge of the bench on a wire screen or towel so it can't roll off. When a thermometer breaks, The glass and any liquid that spills out must be cleaned up and disposed of properly. This is a job for your teacher. Glass fragments can be swept up. If any alcohol happens to escape from the glass, it can be wiped up with a paper towel. Cleaning up a broken mercury thermometer is more difficult and also a job for your teacher. Mercury is poisonous and it won't soak into a paper towel. Mercury vapors also can escape into the air. If you work with mercury thermometers, your lab may be equipped with a mercury cleanup kit or sponge. The kit and broken glass should be disposed of in the proper container. Don't shake thermometers. Use thermometers only in the temperature range they're suited for. Lay thermometers down on a towel or a wire screen to cool, away from the edge of the bench. Let your teacher clean up broken thermometers. The most common lab injuries are cuts from broken glass, especially glass tubing. A typical accident comes from using too much force to push a tube through the hole in the stopper. One way to avoid this kind of accident is to use an inserter. First, dip the Teflon tip in a glass lubricant such as glycerin. Then push it through the stopper. Remove the tip and slide the tubing through the hollow inserter shaft. Removing the shaft leaves the tubing behind. Make sure to wash the lubricant off the tubing and stopper before using them. And replace the Teflon tip so it doesn't get lost. To remove the tubing, take out the tip and lubricate the end of the hollow shaft. Push it through the stopper hole around the tubing. Then slide the tubing out through the shaft and remove the inserter. Remember to wash the lubricant off before returning the stopper and tubing to storage. And don't forget to replace the tip. If you don't have an inserter, lubricate the tubing instead. And protect your hands with leather gloves. Push the tubing gently through. Rotate it if there's any resistance. Use the same care when removing it. And don't forget to wash off the lubricant. Use an inserter to place glass tubing in a stopper or remove it. Or lubricate the tubing and protect your hands with leather gloves. A centrifuge spins mixtures around in test tubes to separate solids from liquids. The solids move out toward the bottom of the tubes and the liquid stays on top. When the test tubes inside aren't evenly distributed, the centrifuge is unbalanced. It vibrates like a washing machine with an unbalanced load. If the vibration is bad enough, it can fall off the bench top. To prevent vibration, a centrifuge must be balanced. If you're only centrifuging one test tube, place another one opposite it with an equal amount of water. Once the centrifuge is balanced, you can turn it on. When it's finished, turn it off. Then wait till it stops spinning on its own. Never try to stop a centrifuge with your hand. Place equally filled test tubes in a centrifuge to balance it. Don't try to stop the spinning with your hand. A safe lab session starts with proper clothes. You must wear clothing and equipment that will protect you from chemicals and flames, and at the same time, stay out of your way. For example, sleeves that are too loose can drag through a chemical puddle or knock things over. The wrong material is also dangerous, as this mannequin demonstrates. Fuzzy sweaters or filmy fabrics can easily catch on fire. Synthetics such as polyester melt when they burn and stick to the skin. The right kind of clothing includes sleeves and shirts that fit fairly close, but aren't too tight to restrict movement, and fabrics made of sturdy cotton or wool that won't melt and stick to your skin. A lab apron keeps most splashes off your clothes, but you should still wear older clothes underneath in case any chemicals get past the apron. Legs are vulnerable to chemical splashes and broken glass if you drop something, so long pants or a long skirt should be worn to protect them. Open shoes can't protect your feet from spills. Closed leather shoes are much better. And shoes made of cloth or woven material can absorb spills and hold harmful chemicals against your skin. Besides wearing the right clothes, there are other precautions you should take to avoid accidents. Tie up loose, long hair. It could knock something over or even catch fire. Remove rings and watches. They can trap corrosive chemicals against your skin, and the chemicals can damage your jewelry. Your eyes are the easiest to hurt and the most important to protect. Don't wear contact lenses in lab. They may trap chemical vapors against your eyes. If that happens, your eyelids may go into spasms that make it impossible to remove the lenses and wash out the chemical. Always wear goggles with side shields to completely protect your eyes, even if you're already wearing glasses. And finally, protect your hands. Never use bare hands with concentrated acids, bases, or other reactive chemicals, such as concentrated hydrogen peroxide. Your teacher will tell you what type of gloves to wear to work with these chemicals. With the right clothes and protective equipment, you can work with laboratory chemicals with confidence and safety. Don't wear extremely loose clothing. Fabrics should be sturdy and natural. Wear older clothes and cover them with a lab apron. Wear long pants or a long skirt to cover your legs. Wear closed leather shoes to protect your feet. Tie up long hair. Remove rings and watches. Take out contact lenses. Cover your eyes with goggles with side shields. Protect your hands with the right kind of gloves. A chemistry laboratory is full of beakers and bottles holding chemicals. Fooling around can have disastrous consequences. You could scar yourself or others for life, even cause blindness. So the most important rule of all in the lab is no fooling around. Don't run, push, or wrestle, or even move fast. Even if you're not fooling around, accidents can happen.
Wait a second.
Personal belongings in the middle of aisles can trip someone. Even a job as simple as reading a burette can lead to an accident. For greatest accuracy, your eyes should be on the same level as the number you're reading. If you can't read a burette accurately, lower it down to eye level. If you can't do that, stand on a step stool. There are behavioral rules to protect you against less obvious hazards too. Applying makeup may seem harmless enough, but chemicals and vapors and spills in the lab can contaminate it. Then when you apply it to your face, you put on the chemical too. So keep makeup outside the lab. Eating and drinking in the lab can cause similar problems. Chemicals can contaminate your food or splash into a drink.
Guys, I think it's time to go to class.
Get rid of them before you come into the chemistry lab. Don't fool around in lab. Keep aisles clear of personal belongings. Stand on a step stool when you have to reach. Keep makeup in your purse. Keep food and drinks outside. In spite of safety precautions, people sometimes get careless and accidents happen. That's why a well-equipped chemistry lab has emergency equipment to take care of them. If you've cut yourself, wash the wound to remove any chemical traces. Make sure there are no pieces of glass in the cut. Dry your skin carefully so a bandage will stick. Let your teacher put the bandage on the cut. Notify your teacher whenever you have an accident, and make sure to get immediate medical attention after any injury in the lab.
This is very important. Let's say something happened accidentally. Please notify me as soon as possible. I remember when I was taking Orgo 2 lab, one of the students in the lab class had sulfuric acid on him. He waited about 5 to 10 minutes to tell the instructor at that time, and he started burning. So thank God the instructor knew what to do in that case, but he was still admitted to the hospital. So please don't wait to tell me something you think, you got this on your hand or you think something else happened. Notify me immediately because it's for your safety. Okay?
Chemical spills and splashes are also common lab accidents.
You okay? My eyes. Let's go wash them out.
All right, what's the dumbest thing over here, guys? What was the student not wearing?
For safety goggles.
Exactly. This is, as soon as we start, the first thing I need you guys to do is always wear your goggles. Exactly. So this thing shouldn't even be in. It would have protected her eyes so much better if she had goggles on. And also a quick story. Dr. Look also had the same accident when he was a grad student. He didn't have goggles on. He accidentally got acid in his eyes. Thank God nothing happened to his eyes. But from that incident on, he always wore goggles in lab. Always. Okay? So that just goes to show you how important safety is. Even when you think it's not, nothing will happen, something could happen. Okay? And also even I had goggles on at one point, and in the lab that I work in, I actually got a chemical called dichloromethane in my eyes, and I had to wash it out with water. Thankfully, it was a small amount and nothing happened. So safety is very important.
Chemical hits your eyes. Wash them immediately in an eye wash fountain. Hold your eyes open and roll them around so the water can wash them thoroughly. You shouldn't be wearing contacts, but if you are, get them out as soon as you've given your eyes a good initial rinsing. Continue washing for at least 15 minutes. Then see a doctor immediately to check your eyes for damage. Non-corrosive chemical splashes on bare skin should be rinsed off in the lab sink with plenty of water. Spills of corrosive materials require a lot more water. Don't wait till you feel pain from the chemical. Head for the safety shower immediately. Rinse your body thoroughly as fast as possible. Take off all your clothes. Don't let modesty make your injury worse. Your teacher will clear the other students out of the room. Stay under the shower for at least 15 minutes. Fires are always a potential hazard in chemistry lab, especially when organic liquids are involved. Small fires in containers can often be put out by covering them. Turn off the burner so the fire won't reignite. Larger fires require a fire extinguisher. It should be operated by a teacher, not by a student.
Hey, fire! No, let's leave.
If the fire is too large to control, clear out of the building. Call the fire department when you're safely outside and tell them what chemicals are involved. Clothing fires can be put out in a couple of ways, as the mannequin will demonstrate. The best way is in the safety shower. If the shower's not close by, the rule is stop, drop, and roll. The victim's weight on the fire puts some of it out, and a fire blanket gets the rest. Flames should be kept away from the victim's face. Anyone who's been burned must get medical attention immediately. Clean and dry the skin around a cut before a bandage is applied. Rinse chemicals from your eyes in the eye wash fountain. Rinse chemicals from your hands and arms with water in the sink. Remove your clothes on the way to the safety shower to rinse large spills from your body. Extinguish small fires in containers by covering them. Let your teacher use an
All right. In
may
the
look
essence of
serious,
time,
and many of them are.
really nothing else left, and that's the video. Okay. All right. Any questions about anything so far, guys? Nope. All right. So if no other questions about anything, you guys are free to. I'm not gonna give you guys want a quiz. Anybody wants a quiz? All right.
No, Professor.
What do you do if you get something in your eyes?
We wash it off.
Yes, 100. Everybody gets 100. Good. All right. No quiz. Everybody gets 100.